Okay, my name's Michael Dine, and I do research in elementary particle physics in University of California at Santa Cruz. My work is theoretical. Okay, so it means that it's a lot of paper and pencil or computer, and largely done here at Santa Cruz. Okay, so I'm dependent on results from laboratory facilities, places like the Large Hadron Collider at CERN, but I don't actually frequently go there. I travel sometimes to meet colleagues and so on, but I'm largely here. Um, my work, I started doing this kind of work a long time ago. I've been at Santa Cruz for uh, over 25 years, doing work in theoretical physics. I've had many students, both graduates and undergraduate students working with me. Um, the work, what drives me is trying to understand the laws of nature at a very basic level, both trying to understand the parts we understand better, or try to, so this includes, so we understand things like the strong force very well, the strong nuclear force, but there are things we don't understand so well, and so my work is sort of divided between trying to improve our understandings of the things we already understand reasonably well and trying to figure out what's new, what might be, what are we missing. So these are two aspects of, of the things I do. I became interested in this kind of work actually as an undergraduate. I had faculty I liked and teachers and advisors who exposed me to interesting topics. But over this long period of time, the field has evolved, new kinds of questions have arisen, and it attracted my attention. So my interests range over things like, as I say, things like what is the strong nuclear force, but also things like what is the dark matter. So I've spent a lot of time on various candidates for what might be the dark matter. We know that most of the matter in the universe is some form which is unfamiliar, and so one proposal is something called the axion, which I've been involved with, both proposing it and in trying to understand it through the years. There are ideas associated with massive particles, perhaps due to something called supersymmetry or maybe something else, which I've also worked on and been interested in. Other questions in cosmology also occupy my attention. Something called inflation, for example, is something once upon a time was quite speculative. It's now well established at some level experimentally, but there's a lot we don't know about it. So we know the universe went through some period of very rapid expansion, but we don't quite know why or what the laws are that govern that. And so that's, again, something I spend a good deal of time on. And in terms of my students, recent graduate students have worked on some of these questions about the nuclear force, have worked on questions about possible new symmetry of nature called supersymmetry. Undergraduates recently have worked on a variety of projects. One involved tunneling in quantum mechanics, sort of motivated by some questions in cosmology, but actually in the end related also to actual devices that people build and so on. So, and we discovered that sort of textbook treatment of some aspects of tunneling leaves something to be desired. And some of the students, two students have gotten theses, for example, out of working on that. So in terms of reaching me, students can knock on my door. You can email me and make an appointment at mdine@ucsc.edu. You can find the email address on the website, and I'm generally very happy to meet with both graduates and undergraduates. So don't hesitate to get in touch with me.